Multi-stage experiment. So independent events where the outcome of one has no effect on the outcome of another. And I guess tossing a coin is a simple example of that. Toss a coin once, it has no effect on the outcome when I toss a coin the second time. They're totally independent of each other. So if we have these independent events, then to work out the probability of them happening in succession, we just multiply the individual probabilities together. Yahtzee, great game. You ever played Yahtzee? That's the one where you roll 5 dice and you've got to get all sorts of possibilities. We want to know the probability of rolling exactly 4 sixes. So you're rolling 5 dice. So 4 of them are going to be a 6, 1 of them is not. So you've got all of these possibilities. I could roll 6, then a 6, then 6, 6, then not a 6, or 6, then a 6, then a 6, then not a 6, then a 6, or 6, then a 6, and not a 6, then a 6, then a 6, or 6, then not a 6, then 6, then a 6, then a 6, or not a 6, then a 6, then a 6, then a 6, then a 6. Now working out all of those probabilities, for the first one will be 1 and 6 times 1 and 6 times 1 and 6 times 1 and 6 times 5 and 6, then the next one, and so on and so on and so on. It ends up being 25 out of 7,776. Of course, the way you could have done that one, because the order does not actually matter in that one. The probability is not going to change. Remember, they're independent of each other. So I could have just said there's going to be 5 lots of just the first case, because each one of those is going to have the same probability. So then it's just 5 times 1 on 6 times 1 on 6 times 1 on 6 times 1 on 6 times 5 on 6. We get the answer a lot quicker. However, if they're not independent, then you got to consider different cases. Because look at this one. We're going to get 2 letters of the word lotto and randomly arrange them. So what's the probability that the arrangement we end up is TO, the word TO? It's not equally likely. See, the probability of picking a T is different to the probability of picking an L, for instance. So it's not true to say, well, I'm going to pick a T, that's going to be 2 in 5, and then I'm going to pick an O, and now it's 2 in 4 because I've already used up 1 letter and gone, our probability is 1/5. Well, no, that actually is incorrect, because there's all your possibilities. I could have LO, TO, OO, TL, LT, TT, OT, OL. So looking at that, we'd say the probability is 1 in 8, not 1 in 5. So sometimes it's not as straightforward as we originally think. When we start looking at our extension 1 ideas of perms and comps, we're going to see ways of looking out for this and making sure we get it correct. But for now, we'll just do these questions out of 12E.